it's working. Hooray. Today we're looking at repetition, and on at first glance, we've got 2 minutes left to go, so I'm not going to get started properly. What I'm going to do is do some sharing. Sharing is caring, caring is sharing. Make sure that'll be on there. So all I need to do is, hopefully it's on the Making Maths Fun group, because the whole point is to get it on the Making Maths Fun group. So let's see what we're sharing. So we've got 1 minute left, 1 minute to go, and we're going to make some amazing discovery, fascinating discoveries about numbers. So this is for anybody that's 11 or older. Now what we're going to do, we've created a schedule so you can see the schedule, which ones are going to apply to you. And I'm also, for littlies, we're going to do that at a slightly different time. So if you're 6 and under, there'll be special sessions for the early year learners. And oh, share, we'll just share now. We'll just go with that. Share. It's not 9 o'clock. Oh, it's 9 o'clock now. Got one more share to do if I can. Or maybe if I play it, then it'll work. Cancel that down, put it on here, and we'll be ready to start so that I can see what is happening. Right, hello, we've got someone here. So today's session is for 11 plus. We're going to be setting out a different time for early year learners, and there'll be sessions on different days of the week. The announcement will be out shortly. Different days of the week. Today it's 11 plus, and it's called repetition. And you're going to be discovering, if you get any learners in your household that are 11 and up, and that includes you, any grown-ups that might be here, and let's do it. Let's make some discoveries about numbers that repeat. Now we're talking about numbers that repeat where the remainder repeats. So we've got repetition after the decimal point or the comma, depending where you are in the world. I'm looking for a way to this is always my lovely, looks like it's on there, but how do I share it? It's an internal mystery. I don't understand how to share it. If I go, wait. If I go to my own profile, maybe I'll be able to just make a watch party from there. I'm sharing on there. Can I make, it's all very mysterious. Be honest, Caroline. I'm Caroline from Bubbly Maths. Be honest, Caroline, be with you in one moment. If anybody, start. Right, I started a watch party. Okay, we've got 3 people looking on there. And start, I've got to press start or else it won't work. Start. Right, we've now got a watch party going. Hooray. So that's going to be on there, and that's going to be on here. And I'll just keep an eye out. So what are we going to do? So you'll need a calculator and a piece of paper and a pen. So I've got all my nice colourful pens because I like colourful pens. Need a calculator. I've got my phone, any kind of calculator. And you will need, for the first thing we need to do, you won't need a calculator for at all. So we've got the number. Now let me see, this should now be working, which means, hooray, this is the first time in quite a long time that we can use the visualizer, which is very exciting. Very, very, very. So hello, Andy. Hello, Russell. Right, we're using the visualizer. I'm so delighted. The visualizer is working. The visualizer is working. I did some updates and I did different things. So, right, here we go. This is what we're going to do. We're going to take this number here, and I've got to draw it upside down. So 1, 2, 1, 2, 1, 2, 1, 2. Now I'm I'm hoping that's the right way around. In theory, the visualizer is going to show you the right way around. 1, 2, 1, 2. Let me have a look on Facebook and see what I can see. make sure it's coming out the right way around for you. And if it isn't, I can't do back to front. It's 0.121212121212 to keep going, and multiply it by 100. Now you might not have to do that on a calculator. You might be able to just do that. So just go ahead and multiply that. Sorry, dot recurring 0.12121212121212121212 times 100. What are you going to get? Just look, see if I can find. See, make sure this is coming out the right, the white way wound. Coming out the white way wound. So that's going to be on there. I'm looking on there, and that's. And I'll just keep an eye out. So, what are we going to do? I'm now wait. Oh yes, yes! My visualizer is amazing. I love my visualizer. It looks wrong to me on here, but it looks right to you on there. Okay. Oh, let's turn the sound off there. The white way wound. Oh dear, I think I'm losing the plot. Cancel. And get rid of the sound so that I can see what I'm doing. I can see if somebody comes on, but it's not going to stop me. So have you got it? So what you can do is basically it's 2 decimal places. So it's 2 decimal places. So it's going to be 1 2 point 1 2 1 2 1 2 whoopsie 2 1 2 1 2 dot 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 dot. Okay, what does this mean? We're looking how to relate these repeating numbers with a fraction. So let's now take that away from that. And if we take that, so basically we're going to, instead of taking timesing by 100, we're effectively going to times by 99. So if we want to times it by 1 less, then we'll take whatever is times by 100 and just take 1 away, because the thing that we're making groups of, the thing that we have 100 of is 0.1212. So in order to get 99 times that, all we have to do is work out what 100 times that is, which is that, and take away 1 amount of those. So what is it? What is 99 times? So 99 times 0.121212. I do love these recurring numbers. They're lots of fun to work with, and they do some fascinating things. So 99 times that is the same thing as saying 100 minus 99 times that. Well, we know what 100 is, and we only need to take 1 away. That's equals 1. So we only need to take 1 of these away. So we take that one, take 1 of these away from that. So 12.12, here we go, 1 2 1 2 1 2 recurring, minus, sorry, minus, let's get this right. Yes, minus, so this is 100 times, so this is 100 times 0.121212, and this is just one of them. So just one of them is 0.12212 recurring. What's the answer going to be? That looks pretty complicated. 12.121212 recurring minus 0.121212 recurring. What is the answer? Minus, so it's 100 of them minus 1 of them, which gives us 99 of them times 12.12 recurring is simples. It's 12. It's just 12. That's it. It can't be that simple. Surely. Times this recurring number by 100, you get that. And then take 1 of those away. to get to basically eliminate all of that, because we're taking away one of those, which is all of that, and that's the same thing. So that gives us 12. So 99 times 0.12 is 12. So what? Okay, so that's kind of nice. It's nice and tidy. It's nice and neat. It's nice to look at. But so what? How do fractions and have you ever wondered, like, okay, why do I have to keep converting fractions and decimals and decimals and fractions and fractions, decimals and decimals and fractions? It gives you agility. Sometimes you really, really need to know, like when you're working with percentages, you need to know what the decimals are. And sometimes with fractions, especially when you're doing, when you're getting numbers together that you have to multiply and divide top and bottom, and you want to deal with fractions, there are times when fractions are the best way to go, and there are times when decimals are the best way to go. And in order to convert from one to the other, then what you want is agility, what you want is fluency, what you want is really good understanding of the way that fractions and decimals relate to each other. And this gives you a deeper understanding. And hopefully it shows you a little bit of the fascinating, just this one little aspect of the fascinating world that you can uncover as you explore mathematics, because it is an exploration. It's like, okay, so the world has been explored. We have discovered most places at least above the level of the water on our planet. There are places, but not very many places where nobody's been yet. But that doesn't stop it being fascinating to go and explore for yourself for the first time. That is how you can really enjoy mathematics. So we're going to explore for ourselves and discover the fascination in these repeating numbers. You ready? We've got the repetition. So 99 times so 99 times this number gives us 12. Now, what does that? I'm now going to write a fraction that is 4 over 99. Oops, wrong fraction. 4 over 30. This is quite interesting, writing upside down. That's the one we're looking at. 4 divided by 33. Where does that come from? Well, why don't you just do 4 divided by 33? Just go get your calculator and just do that. Do 4 divided by 33. Hi, Jan. Hi, Terry. This is a session for 11 plus learners that are 11 plus, and that's actually, it's going to be helpful for anybody that's 11 and older, anybody that actually grasps the concepts. It's going to be useful for them when we're working out how we're discovering new things about the relationship between decimals and fractions, and deepening our understanding so that we've got more fluency and a hunger to explore the amazing world that are mathematics. Okay, hi Marina. This is for 11 plus. So if you want to share it with anyone, this session is for 11 plus. And if Leo's watching, hello Leo, it's Grandma. I'm going to be doing sessions specially for you and other young, other 5-year-olds at a different time, and I'll tell Mummy when it is. That's for my grandson. So, and if you can share this with anyone where they might have an 11, and anyone 11 and above, that where you want them to discover how fascinating numbers are. So have we divided 4 divided by 33? So 4 divided by 33 is, dun, 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 dun. Where did we start? We started with this number. Now I've kind of come up with that randomly, perhaps. But 4 divided by 33 is 0.212121212 recurring. Now, is that random, or have I actually discovered that? Can you see a connection here? let me see, maybe I should write this out a little bit more carefully, because we started with 0.012 recurring. We times it by 100 to get 12.12 recurring. Then we decided we wanted to take 1 away. Now this seems a bit random. Why are we doing this? It's like, no, why? Why should I do this? Well, doing it to discover magical things. So 100 minus 99 is 1. And 99 times 0.12 recurring is the same as saying 100 times 0.12 recurring, which is this, minus 1 times 0.12, which is this. So 12.12 recurring minus 0.12 recurring is 12, which is also, so it's therefore 99 times 0.1212 recurring, which is equal to 12. Let me just write that out properly. From this, 100 times minus 1 times 0.12 recurring is, I'll do it even better here, 99 times 0.12 recurring equals hold on, 12, that's right, equals 12. So it was the same thing as 100 times minus 1 times, which is the same as 99 times 0.12 recurring, which equals that minus that, which equals 12. We just literally taking away all the 1, 2 recurrings to leave just the 12. Right, so we've got that. Now, if we look at this, we can now simplify, let's say, or solve, not exactly solve because we don't have an unknown, but we can make this into a fraction. We can make it into a fraction that is, if we now bring, we've got the 12, let me just keep that visible but make it on another page so that we start at the top of the page. So 99.12 times 0.12 times 12, we can write it as, I'm not going to move the 12 to a different side, but I'm going to move the 99 to a different side, equals 0.1212. I'm kind of doing it backwards, but it's because I'm moving these around that way. So when I want a fraction that is, basically I want to know what the fraction is for this number. And I've derived it by finding out what 100 times that number is, taking 1 away to get 99. So 100 times is 12, 99 divided by 99. So we're now going to simplify 12 over 99. And 12 over 99 simplified, well, number 3 goes into both of those. So 3 makes that, whoops, see, get it right, gets that 4, and divide that by 3, makes that 33. Now, what was it I asked you to divide? 4 divided by 33. Right, now, there are lots of other ways of doing this. So, now I want you to look at 0.4444. My goodness, that's not even, that doesn't even have 2 numbers, that's only got 1 number recurring. Multiply this number by 10, what do you get? It's pretty simple. You can do it one of 2 ways. You can use a calculator if you need to, but we're just basically multiplying by 10. So instead of the decimal being there, we've effectively moved the decimal there. So the meaning of that number has now become times 10. Each of these numbers has become a factor of 10 greater, so that's 4.4. So this is times 10 was 4.44 recurring. Now, what if we subtract that number from that number? Have you seen this before? Does this look familiar? Minus 0.444 recurring. What are we going to get? Easy peasy, lemon squeezy. We get 4. Now, can you find the fraction? Remembering what we did before, can you find the fraction that's going to give us the decimal 0.44 recurring? Remember how we did it for the other one? We took one away, and therefore, I'll just let you think about it for a minute. Just let you think about it. Okay. So we have by taking one away, we've taken 1 times 0.044 recurring away from 10 times 0.44 recurring, taking that away. So what we have come up with, so 4 is, which equals 4, and so 9 times 0.4, it's really hard to write upside down. Recurring, I'm going to get good at this, aren't I? I'm going to get really good at this. 9 times 4 recurring equals 4. Can that possibly be true? So what is the fraction? If I've got this right, looks to me like the fraction, if I've got it right, it doesn't matter if I don't have it right, because if I have made, I don't believe in mistakes, by the way. I believe in magnificent mistakes. And this has been, I've been working in primary maths for so long. I'm an engineer, I'm an electronic engineer. So I had to do a lot of maths to be able to get my degree in electronic engineering. But I haven't done this kind of maths for a long time. So I'm diving in to help out in this with home learning. And I'm going to become really good at maths again, like I was when I did my in those days, O levels and A levels. And engineering. So what is 4 divided by 9? I'm going to do it on, I don't have access to my phone. Who else have we got? Hi, Melissa. Hi, Ian. Hi, Anetta. Hi. Hey, Stuart. How are you? I hope you stayed on. So this is math 4. I'm going to put it back down again for 11 plus year olds. And what we're doing is we're discovering the fascination. We're being explorers. We're exploring the fascination that is mathematics. And now I'm going to do this calculation. What did I conclude? I concluded, and I've lost it. It's gone. Oh no, I didn't write it down. That's right. I didn't write it down. So from this, I've concluded that 4 divided by 9 equals 0.44 recurring. So I've found a fraction, and I'm hoping equals, this is what I think. I think that 0.44 recurring is 4/9. That's what I've worked out. Let me see if it's true. Open a new tab. 4 divided by 9 equals 0.444 recurring. Oh my goodness. Well, that's a relief. This is, I'm discovering this at the same time as you, by the way. I haven't done this kind of maths in many, many, many years. So the next challenge is, so if we have 2 numbers recurring, we times by 100 to find out, basically to find the whole number by which we can find the fraction. So if we have one number recurring, we only need to times by 10. So we only need to we need to stop that repetition. We need to effectively take away the, can you see what I'm doing here? Just double checking you can see what I'm doing. We just need to take away what's behind the decimal point. So that's what we're doing. So if it's only 1, we only need to move that decimal 1 place. When we had the 1, 2, 1, 2 recurring, we only needed to move the decimal place 2 places. So that was 100. I'm going to put it here. That was times 10. That was times 100. And then we could, whoopsie, take away the decimal places to get the whole number, and the amount of times we had to, and it's whatever that is, minus 1 is going to be the bottom of our fraction, and whatever comes out that's in the units place or about to the left of the decimal point, that's going to be the top of our fraction. So what if we had, here we go, 0.234, 234, 234 recurring. What do we have to multiply that by to extract the recurring numbers and therefore work out what our fraction is? Whoopsie, you can't see it. There you go. So if we moved it 1 place, is what is left recurring? Not yet. Move it 2 places, is what's left recurring? Not yet. What if we move it 3 places? Then 234, 234, 234, what we have left is recurring. So multiplied by 1,000, which gives us 234.234 recurring. Maybe I should write it one more time. 2, 3. It's just really hard. Recurring. So what do we have to take away from this to get a whole number? We have to, so we've got 1, that's 1,000 times 0.23424 recurring minus 1 time that. So that's just simply 0.23423. It gets worse, recurring, which gives us 234, and 234 minus, wait a minute, that's 234. Yeah, that minus that is 234.2. I'm just going to write it 1 time because I can't do it upside down too many times because it's driving me bananas. 0.23. Whoa, you can't see what I'm doing. 234. It's no loss. Look at this. I'm starting to look like hieroglyphics. 234 recurring equals 234, which equals, which is the same as 1,000 minus 1, 1,000 minus 1, is 999 times 0.23. Have I got this right? That times that. That minus that equals 8. Yes. 234, 2, 3. This is so hard. 4 recurring. I'm having to write this upside down. Therefore, 234 divided by 999 equals 0.23424 recurring. Now, can this be simplified? What is the fraction? So what I'm going to do is I'm going to show you some, and then 2, what you have to multiply this by if the recurring is there's more numbers in it. If it's a much longer, so let's say we've got one here. Well, you'll see it in a minute, but let's say it's just 1 point. I'm going to keep it simple. 1, 2, 3, 4, 5. 1, 2 recurring. So it's going to continue 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. What do you have to multiply that by to extract the whole number and find out what the fraction is of, whoopsie, to extract the whole number and find out what the fraction is that gives that recurring fraction. So here we go, we've got a few. Now this is there's a link to this at the top of the page. I'm also going to put a link to it under this live so that you can see these are, the challenge here is, can you see, focus, 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 focus. Please focus, give me some light. What I'll do is I'll take a picture of it and put a picture on so you can see it. But it's also, there is a link to this challenge. And the idea is to figure out which of these fractions matches which of these. But don't do it by dividing. Do it, if you do it by dividing, it's easy, but you'll learn less than if you do it using the method we've just used. And it's all in the resource, so you don't have to remember everything I've done. It's all in the resource. You can watch the video again, and there will be a much clearer video as well we're creating a YouTube channel called Maths Toys. Hi, Stephen. We're creating a YouTube channel called Maths Toys, and on that, I'm just going to see if there's anybody else looking on here. Okay, I don't see anyone at the moment. So on Maths Toys, it's called Maths Toys YouTube channel, and there's also the Bubbly Maths YouTube channel where these kind of lives, these almost improv lives, will go on. On the Maths Toys YouTube channel, they'll be much more structured, so that it'll be easy to follow and very clear as to why you're doing what you're doing. So what we were doing here is we're being mathematical explorers. We are discovering the world of mathematics in the same way as it's fun to discover new places on Earth. What my mission in life is to help you discover fun, fascinating, beautiful places in your mind about the world around us, which is described by mathematics. The very fact that numbers do these amazing things is fascinating. It's my job to open up the spark in your mind to become fascinated and curious. And the more you discover, the more fascinating it becomes. And why not? Why not absolutely love every single aspect of your life, including discovering the amazing world that are mathematics? So please do subscribe to the YouTube channel. That's Maths Toys and Bubbly Maths. We're just in embryonic stage at the moment. Going to the AIMSEC Facebook page. There's little activities to do every single day, in addition to these lives that we're doing here with the Bubbly Maths, making maths fun for kids of all ages. This is all in aid of helping your home learning to be more interesting, more fun, and make a real difference in your life. So So thank you for joining us. We're going to be doing 11 plus 11 to 15 several days a week. We're coming up with a schedule so that you know what days we're going to be doing which kind of activities. We're going to do family learning on one day, and this is really not suitable for younger children, but you can still play with fractions and find fascinating things. Maybe teach younger learners in your home. Teach your grown-ups what we've just covered here. See if we can get them to be enthusiastic about mathematics as well. So thank you for joining. Will be another live tomorrow, and right this minute, can't remember what it is, but we'll cover it at 9 o'clock to 8 o'clock tonight, 8 o'clock London time tonight. We'll do the preparation for it, and this is all just happening. It's all happening. We're learning as we go. We're creating a structure, and in a month's time, it'll all be very much structured, and we'll know exactly who's doing what, when, and how. And there'll be a lot more videos on the YouTube channels. But in the meantime, please do subscribe to the YouTube channels, and you'll be informed whenever there's new videos going up. Thank you for joining. See you later. And I can't see how to stop the live. Here we go. I found it.